So today for our presentation, our group is presenting a cortisol sensor, which measures the amount of stress within a person's body. Stress has become a more prominent and harmful thing across the nation and internationally. So by measuring the cortisol, we've come up with a solution to try and help with treatment. Presenting today, we have Madeline Hoffman, Morgan Learned, April Ocampo, and Eric Robesoff.
In order to determine stress levels, we will be testing cortisol levels within the body. So cortisol is one of the body's natural stress hormones along with adrenaline, and it is responsible for controlling mood, motivation, and fear. In order to detect these changes, we will have biosensors which will bind to the cortisol receptors, and it will take that data and apply it to and it will take the readings and transmit it via Bluetooth, and that will send the data to an app on the phone, and it can be logged efficiently and effectively. This will use a consistent time period of measurements, and that'll get accurate and reliable data because there are different sweat levels throughout the day, and that is just a biological cycle of ours. And using this data, medical professionals will be able to diagnose problems or recommend treatments to patients with high or low cortisol levels, and the total cost for this device would be around $220. So the effects of stress affect the brain, cardiovascular system, skin, joints, muscles, gut, immune system, and reproductive system in many non-favorable ways. It triggers the flight or flight body response, and that prompts the nervous system and endocrine systems to release cortisol and adrenaline hormones. And that is okay for short periods of time, but once it becomes a chronic issue, it disrupts the body's steady state conditions, which alters the immune system, and it suppresses the digestive and reproductive systems, which really factor into our day-to-day lives when we're trying to be healthy with the food we eat and whatnot. So the chronic stress can cause heart disease, mental health issues, sleep disorders, decreased hormone production, and a whole slew of other issues.
So competition analysis. Out on the market, there are a couple different options to try and help measure stress levels. Smartwatches and fitness trackers feature like a heart rate monitoring system. These tend to run for anywhere from $100 to $430 each. Some of these disadvantages is that they're not as accurate, and it doesn't always recognize the difference between actual stress or exercise. There are also other options such as at-home cortisol test. These run anywhere from approximately $50 to about $130. They go ahead and take saliva samples that are later sent to a lab to be examined. Unfortunately, this has long periods of wait, and it can be costly if you have to take multiple tests to get more data options there. For our design specs, our product models similarly to an infrared thermometer. To cut costs, it'll also be made of plastic, which will protect the internal components of the device. This weight will come out to 115 grams prior to batteries or anything like that. It'll also be portable and not attached to a power cord, so this makes it easier for the person to go ahead and swipe it across their forehead without the worry of like catching themselves on a cord or anything. The permeable membrane on the face of the device will allow for cortisol to collect and bind to the ion selective field transistor, which will sit right below that membrane. This mimics the glucocorticoid receptors within the body. The transistor also calculates these values from measuring the change in passive positive ion flow from the sweat that permeates the membrane surface. The bioreceptors will then process that data and transmit the information to a data logging app via Bluetooth to make sure that this data is stored easily and securely. It's an effective and efficient way to make sure that data just stays in one place. It's not being written down anywhere and accidentally thrown away or something. It's recommended that these readings take place 15 minutes after waking up and 15 minutes before going to bed, as this will create a consistent time period at which you're making measurements. as well as the body fluctuates with its cortisol levels throughout the day. In the morning, you tend to have higher cortisol levels, given that when you wake up, you have a little bit of adrenaline, which also goes hand in hand with cortisol, so therefore you have higher levels. When you are about to go to bed, you will have lower cortisol levels, lower adrenaline levels, making it easier for you to fall asleep. Cleaning this product will be pretty easy with isopropyl alcohol, which works as like a disinfectant, and it's pretty universal there.
Our device will be mainly made of 3D printed plastic, which costs approximately $45 per kilogram, and since our device is around 115 grams, this cost will come out to approximately $5 per unit. The main cost for our device will be that ion selective field effect transistor, which costs approximately $200 per unit. The image below shows this device. The membrane component of our device will cost around $230 per 12 inches, and since our device uses a membrane that's 1 inch diameter, this will be approximately 20 cents per unit. The printed circuit component of our device costs approximately $10, and the Bluetooth communicator system will cost around $5.56. Overall, the total cost that we estimate for our device will be around $220. This is a similar cost to other products on the market. However, this device can be used over long terms, so this is effective over a period of time to measure. The initial tests that we'll be performing will be to ensure that our device measures cortisol in sweat, and we will be doing this by swiping our device across a surface that will have sweat placed on it. And once we've determined that our device is effective in detecting cortisol, we'll perform qualitative assessments of the reaction of skin to contact with the sensor head of our device, and we'll be doing this to ensure that there isn't any irritation. The skin that we'll be using for this will be artificial skin with sweat added before we move on to any human testing. Further testing will determine the accuracy of readings from our device through comparisons to other methods of testing cortisol levels, like blood or saliva tests, and the results from this will be levels of cortisol measured by these different methods, and we'll perform a statistical analysis on this data to determine the error between our device and accepted methods of cortisol testing to ensure that our device falls within a reasonable parameter. Later tests for our device will include user surveys to ensure an easy-to-use interface and straightforward methods, and this will be mainly written responses from users to ensure that our product is user-friendly and works for all users.
One of our biggest challenges and main concerns was the accuracy of the readings produced by the device. So for the next generation prototype that we build, one of the things we will concentrate on is the improvement of these readings. The next generation prototype would also include the development of a web application for qualitative data with a user-friendly interface. Along with these improvements, we strive to reduce the cost of the device to improve accessibility. The next step for our team would be to release the product in a soft launch for test trials. This would allow the team to gather data and customer feedback to further improve the device and the web application. We hope to reach the limited audience for this device through healthcare providers. In conclusion, our biosensor will be user-friendly personal cortisol-based stress monitoring system. This device will have a similar initial cost to products that are currently on the market, but unlike other products, our device will measure stress more reliably by basing measurements specifically on cortisol levels rather than heart rate or other parameters. There is also a significant shorter turnaround time for results, as the readings can be easily accessed through the web-based application. And our device is cost-effective for long-term monitoring cortisol levels, since it is a one-time buy. This device will allow patients and healthcare providers to monitor stress levels in real time. Our hope is that by monitoring the level of cortisol in the system, the identification of various stress-related health problems will become easier. Thank you.